Okay, good evening, everyone. Welcome to another live stream for Exercism's Analytical April. My name's Aaron. This is my fourth of four live streams this month that I'll be doing for. No sound? Oh no. Make sure I'm. Just a second. I think I might be having some sound problems, but I'm not too sure. Okay, sorry about that. You know how it goes. You gotta get someone to listen in. Um, so, let me try that again, just in case it didn't work the first time. Welcome to another live stream for Exercism's Analytical April. My name's Aaron. I'm a software engineer based in Boston, and I've done three live streams now for Exercism this month of April. This will be my fourth and final live stream. And as part of this month, what I've been doing is just sitting down and working through some exercises using the Julia language, which is a language I've had the opportunity to work with quite a lot, which is a big part of my day job, which is a big part of my work, both in my time as a graduate student and in my time in industry. So it's not the only language I've used by any stretch, but it is probably my favorite language right now, and has been for a little bit, for several years. So I really like the opportunity to get to go over some of the reasons why I like to use Julia, especially as one of the emphases of these live streams, or at least what I try to do. So what I'm gonna do now is I'm going to share my screen and just get started. Okay, so looking back at the last few times I've done this, I have had the text be a little bit too small. So what I'll do here is make sure this is nice and big. And I'm just going to make sure that I can also see the chat, because a couple of times I have missed some messages in the chat, and I want to make sure that I can see those. Okay, so as you'll see here, you look at my command history, right? What I'm going to work on tonight, at least to start off with, is the custom set exercise from Exercism. So I think I've already downloaded it. Let me see, right? So I do have it here, but just so we can start from scratch here. So in order to download exercises using the CLI tool, presuming you set that up, right? It's pretty simple. Exercism download, and then we can specify the exercise we want to download. I'll even make this a little bit bigger yet, as well as the track. So not every single exercise is represented on all the tracks, right? Some tracks have some exercises, some have others. Julie actually has quite a lot, especially considering the popularity of some of the other languages offered on Exercism. But usually you find them from going on the website first and finding the name of the exercise and looking through that. Right. I'm going to skip that stage and just go straight to here. So we download the exercise, and now I've got it here in this custom set directory. So what I'm going to do tonight, which I've done a couple of times in the past in these live streams, is I'm going to approach this exercise a little bit differently than it's set up, at least as it's downloaded from Exercism. Right? So you won't necessarily be able to solve it one-to-one with what I'm going to do right now, but I'm going to take the opportunity to demonstrate a little bit about how the workflow related to modules in Julia goes, because it's a little bit different than what you might be used to, especially if you're used to a language like Python, because Julia modules are kind of a first-class part of the language, in a way that I think is a little bit clearer to reason about than Python modules can be. And the thing that I'm talking about mainly is the fact that you have to export names in Python modules in a way that isn't necessarily obvious to first glance with the init files and that kind of stuff. Whereas in Julia, it's a little bit more straightforward, at least in my opinion. And also, it's just easier to generate programmatically in a way that you don't necessarily have to remember the structure of how everything works. So what I mean by that is this. So I'm going to start totally from scratch here. Where as you can see, there's nothing else in this directory whatsoever. And I start up my Julia terminal, my Julia REPL. And so I'm going to be running Julia 1.9 tonight. I'm not going to be using any features of Julia 1.9 versus like the last couple of versions, as far as I know. That's just what I have installed by default. I think I mentioned once or twice in the past, and I won't go into too much detail, but just so we've talked about it once tonight, the preferred way to install Julia is via this tool called Julia Up. And this, you just go to their GitHub or wherever you want to download this tool in the first place. And then what this does is it manages versions for you. So I think, I'm sorry, Julia Up list. Right, this will list all the different versions that we can download that are available for download for Julia right now. And there's quite a lot. Typically, you just want to stick with release. I have been using 1.9 just because there's been some pretty substantial improvements to compilation times and caching compilation results in 1.9, which has been useful to me. So I'm just going to stick with that for now. But I'm not going to use any special features from 1.9. So if you're using an older version, there should be basically no difference. So what I can do to get started with a project is just type the right bracket key, right parentheses key, or whichever, how you want to think about that, or right brace key. And that brings up the package manager in the Julia terminal. So this is one of the reasons, a little part of the Julia language that I especially like is that the package manager is built right in, right? You don't have to worry about, is it pip, is it, poetry, is it whatever? We're not going to talk about how it works in C++, right? It's just part of the language. And what I can do now is generate a new package. I'm going to generate a package called customsets.jl. So here are two different kind of patterns that you see a lot in Julia packages. If you have one kind of big type that makes up the package, you tend to call the package, the plural version of that type. We like to use these, all words beginning with capitals for type names and for package names. And then .jl for the package name itself, right? This is a pretty common way to indicate that a package is Julia. Kind of like starting with pi, right, is a good way to indicate that a package is a Python package, like PyCV2 and stuff like that. CPP for C++, that kind of stuff. This .jl is common. And it's common enough that if I do this generate custom sets.jl and look at what it gives me, right? So I'll go in here and actually I'll move this over here. I'll go in here into custom sets.jl and look at what it gives me. Right? It gives me two things. This project.toml file. This is where we track all of our dependencies. Usually, you don't mess with this file directly too much. I mean, you totally can, just pin versions and stuff like that. But especially in smaller packages, and what we're going to do tonight, we're not going to really touch this directly at all. You interact with the package manager directly to do stuff like add packages. Like we're going to need the test package, part of the the core library, because we're going to be running some tests. And if I look here, oh, sorry, I added that to my base environment, as you can see from this 1.9, because I'm trying to do too many things at once, right? So what I got to do first is navigate to my actual project directory. So I can close this REPL and move on, or if I type the semicolon key, I get to a shell prompt, which is kind of neat. And then I can just cd into my custom sets, type my right bracket again to get my package manager, and then type activate. And if I type activate dot, right, for my current working directory, that'll activate this custom sets package. And you might say, hey, here's custom sets. Why isn't it custom sets.jl? Well, in Julia, we call the package itself something.jl. We don't have to, but that's a pretty common way to do it. The files themselves, of course, have the .jl suffix to indicate that they're Julia. But the module, right, which we would declare or set up or define, like this, doesn't include the .jl. In fact, if you include it, I think that will throw an error. Right, so the module itself would just be called custom sets. And if we wanted to, import this, we could do using custom sets. This would import the module and all of its exported symbols. We could do import custom sets, right? We'll get to that in a second, because we'll have to do that in order to run our test suite. And what we can see is auto-generated is kind of this placeholder, right? This greet function that I could call right now if I wanted to. I could say using custom sets, custom sets.greet. And you notice what it did right here is when I brought in using custom sets, right? Julia did some pre-compilation, and of course it didn't take very long because there's basically nothing to compile. Right, but that happens when you first import or using a package, and then when you first call a function on a particular set of arguments. Okay. So now what? How are we going to approach this exercise? Well, in Exercism, the standard way we do it is via a test suite that's already defined as part of the exercise. So that is what got downloaded here in this custom dash set. And I'm working over here in my own little module, just like I said, just so I can kind of demonstrate a little bit about how that works in Julia, about how a typical package workflow looks. Right? So I'm going to do one thing is I'm just going to take the test suite that they've defined and bring that into my package. So if we look at this directory, this custom sets that I've made, customsets.jl, there's one thing that's missing as far as what you would typically see in a Julia package and what you should always include in a Julia package. And that's the test suite, tests. Right? So I make a directory called test, and in it I have a file called runtests.jl. And right now I'm going to make that empty. And the neat thing about that is that if I type my right bracket to get my package manager and type test, it runs my test suite. Right now there's nothing in it, so all of my tests pass. But anything that I put in this file that I've just made, right, so there it is. Sorry, kind of went off the side of the screen there for some reason. In this file I've just made, right, there's nothing in here yet. If I go to the directory containing the Exercism exercise, look at their runtest.jl, this is what I'm going to want to take for our exercise. I'm going to take the whole contents here. I'm going to go back to my test file. I'm just going to plop that right in. And what I'm going to do is the typical approach here, at least that I take, of commenting out all of the tests to start off with, then we're just going to go through them one at a time. And there's also one minor change I'm going to make too to make this work, is instead of include customset.jl, I'm going to write using custom sets. And this is how it would look in an actual Julia package, right? We'd bring in this test package, and then we'd have using custom sets. And what happens if we run our tests? Well, we get a complaint because we've actually technically brought in a dependency in this test package. So Julia does require you to be explicit about this kind of stuff, kind of like Python does with like pathlib and things like that, where you technically do have to import those in order to be able to use them, even though they're really part of the standard library. So all we have to do here is just make sure we're part of our custom, we're activating our custom sets environment and just add test. And that's going to be our only dependency. All of these exercises can be solved without third-party dependencies, and I think they actually need to be solved without third-party dependencies. And of course, after you get all the tests to pass, it's sometimes interesting to bring in some other packages and see how you might do it. But for our purposes here, we're just going to use all base Julia. So now if I run my test suite, again, all my tests pass because I haven't run any. So I activate my first test set here, right? So this is a neat thing feature that we have as part of this test package is we can group individual test expressions into test sets, right? And then all these tests have to pass. If one of them fails, right, the test set will see it and report to us which one it is, right? The whole count how many have failed and passed and that kind of stuff, as we'll see in a second. Because right away, here, I'll close this window here because we don't need this. Because right away, we run into some problems. Both of these tests threw exceptions, and they both throw the same exception. And that's that this custom set type is not defined. So that's where we'll start. All right, we'll go into our customsets.jl, where we define this module. We'll get rid of this placeholder, and we'll just define a type called custom set. And right now, I'm just going to make it this. Because in the spirit of test-driven development, if you only write as much code as we need to get an actual test to pass, and then we move on. So let's see what we get here. And the reason why we like to do this, just kind of as an aside, the reason why we like to have this set up is because this is actually, you know, activating its own little temporary environment for these tests. It's making sure that it's not, you know, caching any of the variables globally like you would in a script or anything like that, right? It's a better software engineering practice to use this kind of setup where we have the test suite defined in this separate file that is recognized by the Julia environment. And as you can see here, right, we have technically brought in some dependencies here, right, but nothing outside of the base library, right? We have logging, we have markdown, we have some serialization, we have our test library. This is pretty typical. Okay, so right, you might notice right now, if I type tests, right, and I run my test suite, we actually get the same error. And that's because I've defined this type custom set. And if I even bring this in and say using custom sets, and then try and access this custom set, right? It's not defined, but what is custom sets dot custom set. So kind of like in Python, what I would have to do to be careful, right, is do something like this, using custom sets, custom set. And then I should be able to access this symbol. But strictly speaking, that's not what they did in the test suite, right? Actually, here, I'm just going to restart this so my buffers are a little bit cleaner than they were before, so it's easier to switch back and forth. Okay. That's not what they did in the test suite. And also, I mean, if we're using a type like this, we don't necessarily want to have to do either this explicit using or import, right? Import would be fine here too. Or make sure to, you know, explicitly prefix it every time like this. And, you know, if you're used to Python, this kind of thing, or, you know, import custom sets, custom set, right? This kind of thing is common in Python and, you know, is somewhat common in Julia, but it's equally, or I would say more common and probably, in my opinion, a bit slightly better practice to instead have, you know, parts of your module that you explicitly export, right? So in our module like this, we would have, you know, export custom set. And this could go anywhere in the module. So modules in Julia are kind of like C++ namespaces in that, you know, we evaluate. You can think about the module being evaluated kind of as a unit. So you don't necessarily have to have the ordering correct in terms of like you don't have to define a function before it gets used or something like that, as long as they're in the same module. Oh, hello there. I just saw your message in the chat. How's it going tonight? So if we do this here, now we'll see. Okay, so we have a slightly different error. So we've exported this symbol, so now we can see this. And actually, let me just start my prompt over again. And this gives me a good opportunity to mention this, and I'll make my font bigger yet again, because I can't be too safe here. One nice little feature here is if I type Julia, right, there's a couple of options I can add, like any command line tool. And if you want to see those, of course, there's always the -- help, and there's quite a lot of information here that we don't really need to get into. But the most useful of all of them is -- project. And if I write -- project equals, or just -- project, what that will do is start Julia. And oops, I started in the wrong directory, right? If I go to a Julia package directory and do this, and then I check my right bracket, I see that I've automatically activated this environment. And of course, you can do what I did before, where you make sure to type activate and all that stuff, and that's not like all that much extra work, but it is kind of nice to be able to do that right off the bat. So I even have this as an alias, right? JP. Oh, maybe on this computer I didn't actually define it, but on my work computer, right, I have this JP, which is Julia -- project, just because I basically never start Julia without doing that. You should always have an environment set up, even if it's for just kind of a one-off. So I have my Julia -- project. We can also do stuff like -t for threads and things, but we, of course, don't really need to deal with any of that tonight. Cool. So I will make this side window a little bit smaller here. Right, and of course, for tonight, I'm using NeoVim and just the terminal, tmux. I usually actually use VS Code these days, and did in the first couple of live streams, but I found especially once the font gets really big, the tooltips were making it really hard to read what was going on. I don't know that they actually showed up in the video, but they definitely showed up for me when I was typing and stuff, and it made it hard to actually see the text. And I'm sure that there are ways to change those settings and stuff, but I decided that it was easier just to go with a simpler tool, especially for demonstrations like this. So I am using NeoVim here, right? I do have a package installed to work with Julia and that kind of stuff. Pretty standard things. I'm not going to go into those kind of details. The one thing that I do miss that I really won't use all that much tonight is stuff like in VS Code, you can select text and run it and stuff like that. That is useful, and of course, you can also do that in Vim, and I never properly set it up. I'm not going to do any of that tonight, but just so you know. So back to business here. If I run my tests, what kind of error do I get? Okay, so I've got some tests that are failing. So let's go ahead and run one at a time, right? I'll comment out the second one, run test again. No method matching custom set. So it looks like we're trying to run a constructor, and we're trying to pass to it a vector of any's, right? Of any type. And does that make sense? Well, let's see what we're doing here, right? We're seeing if this function is empty as defined. We're trying to build this custom set, and we're trying to build it out of an empty vector. In Julia, these are called vectors. And one of the things that I always do, still to this day, even after years and years of using Julia now, is make heavy use of the REPL and its built-in help and all that stuff, right? If I type my question mark, I have this help menu, right? So if I want to read about vectors and the vector type and that kind of stuff, I can do that. And the only thing really, from that was just an example, but actually that might be useful here is just, we do have in Julia, we have this vector type that is kind of like a C++ vector, right? It's dynamically sized and that kind of stuff. It's a little bit more ergonomic, especially with regard to numerics than the vectors from C++, just because it does kind of take after MATLAB and NumPy and that kind of stuff, right? We have like, ones and that kind of stuff. But we can also do things like, basically what we're doing right here is we're starting with an empty vector, right? So if I have vec equals this, we have this notation here. And what this means is that this is a vector of type any. And this in Julia is something that should always kind of raise an eyebrow. There are plenty of times that you do have to do this, don't get me wrong, but especially in performance critical code, this is something you should always try and avoid. Because what this is doing is this is saying Julia is looking at this vector kind of fully dynamically. Element by element, it has to look at the element and decide what type is it and what do I do with this type, right? How do I access its data? What does that even mean? Where is that data stored? Is it inline? Is it a pointer? Blah, 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 right? So what it's effectively doing, right, if you want to think about the actual implementation, is it's effectively, storing up a vector of pointers, and each of those pointers points to the individual elements. And so if you've ever implemented that kind of thing yourself, and you may know that has a performance cost, at least depending on how you do it. And that's what I like to think of Julia as operating in full, I like to think of it as like fully dynamic mode. And the reason why that's a killer for performance is because the compiler can't really do anything about that. Unlike if I have, say, what I just wrote here, vector of ones. So I'll just write vec equals ones, 10. And what this is saying is that the Julia compiler will now know that this is a vector where all of the elements are floats, right? 64-bit floats. They're all in line. And it knows that it can generate inline code without any kind of indirection, without any kind of pointer dereferencing, any kind of that stuff under the hood, right? Unlike in, say, Python, right? Base Python, where we have a list. And each element of that list can be whatever type you want. That's one of the strengths of Python, but also one of the downsides, right? Because that means that every time you go through that list, you have to hit that interpreter and say, what is this? What do I do with it? Whereas in Julia, right, there are plenty of times we do have to do that. But when you can avoid that, you should. You should, either have a vector of homogeneous typed elements. You should provide the type as a parameter when that's appropriate. But in this case, what we're just passing in here is a type any. Unlike the very next case, right? If I did x equals bracket 1. What a little bit different than something like MATLAB, right? Where everything is a complex number or whatever, right? Julia actually does have strong types that it respects, right? It knows that this is an integer. It defaults to 64-bit, right? It will do integer arithmetic, that kind of stuff. So what we want to do right away is define a constructor for this custom set type. Okay, so I go back to my module. And what's the first thing I want to do? Well, we want to be able to pass in a vector of elements. And if I think about what I'm going to want this custom set to do, it's going to have to store a collection of elements at some point, right? So much like in C++, especially modern C++, when you have a collection that you might want to change the size and you don't have a really strong preference for how you're accessing it or anything like that, the first thing you should reach for is a vector. And so what we're going to do is have a single field here that I'm going to call elements, and I'm going to make it a vector. But just like I said, we want to watch out for the situation where we have a vector of unknown type. So what I'm going to do is introduce a type parameter here. I'm going to have vector brace t, and that's going to be a parameter for my type 2. And I'm actually going to have to restart my REPL here because I've redefined this constant here. Okay, so far so good. Let's see what happens if I run my test suite. Okay, so it looks like I've still got an error here. Why is that? Well, we've defined the constructor, right? As I mentioned last time, and as you might be familiar with, I've defined this structure, right? So this kind of looks like a C struct, right? Or a C++ struct if you use struct over class. With the exception of this end, right? In Julia, we use end-to-end blocks as opposed to like curly braces or whatever. So despite the fact that this looks kind of like a C struct, and we often should treat it kind of like a C struct, and that we don't associate functions kind of in line with this, there's no class members or anything like that. One thing that we do get for free is a constructor, right? If I were to say take, using custom sets, I don't know why I keep wanting to capitalize that U, and I do custom set of 123 or 123, whatever. Without having to define it explicitly, I do get, what in Julia is called a default constructor, which is taking all of the different fields in the order they appear and just passing them straight into a function. All right, if I did something like this, custom set 1, 2, 3, it wouldn't know what I mean, right? Because I've passed it 2 arguments instead of 1. It's the only thing I get for free is that one constructor with this one, right, field, because all we have is 1. If I added another field, I'd get another argument to that constructor. And unlike in C, right, where we have to do stuff like, call the function like make custom set, or, have a subscript t or whatever, because we can't overlap the names, we can do stuff like add other constructors, right? So if I wanted to do exactly what I wrote just here, where, I wanted to be able to specify the elements without necessarily wrapping them in a vector, I could do something like this, where I define a function, custom set, and I'm going to call it else, just so we don't shadow the names, even though, the scoping should take care of that. It's going to make it kind of hard to read if we have elements all over the place, right? And I add this ... syntax, right? So this in Julia is the somewhat goofily named slurp. This slurps up all of the elements that you write out, outside of a collection into a collection and then passes them to your function. All right, so what this is going to do, and then I return custom set else. So this says, okay, no matter how many, you pass me a bunch of arguments in a row, I'm going to make sure that it makes sense to put them in a vector. I'm going to stuff them into a vector, and then we're going to pass it to this constructor that you've already made. All right, hopefully this works. I might have to restart my REPL. Sometimes, I think I've accidentally blown something up here. Probably forgetting a little detail. Custom sets. system set, 1, 2, 3. I think I've added some like recursion here. Oh, sorry. It should be like this if I pass it. This. Yeah, okay. I'm actually messing up the syntax here because it's one I don't use too often, so I'm actually going to move on from that for now and come back to that later because that's actually something I don't really need for the test anyway, so let's not spend a bunch of time on that. So what do we actually need here? We do have this constructor that we need, right? If I look at these tests, I do need to be able to construct a set from a vector. But the one thing I haven't defined is this is empty. And you might notice if I try and run this right now, so let me just start over for safety here, and I run tests, I get this error about iteration. Right, closest candidates are, so what the hell's going on here, right? There's no method matching iterate. So what Julia is trying to do here is it's saying, okay, well, you haven't defined a method for this is empty for me. In Julia, we have, instead of having, class members and inheritance and that kind of stuff, we have functions and methods. So there's this function, single function, we think about it, called isEmpty, that has many, many, many different methods for different kinds of collections. And if we want to have an idea, a new kind of collection like what we're defining here, this is one of the functions that we want to define a method for. And it's saying, okay, well, you haven't defined an isEmpty, but I do have some other stuff that I fall back on, right? If you look at the, Julia, most of Julia's base library is written in Julia, which is a nice situation to be in, because if you want, you can actually go look this up and say, what happens here if this type is unknown, and it will fall back on this function called iterate. It will try and, iterate through this object that we passed in and, say, okay, well, we iterate through and check element by element. Of course, we haven't defined that either. And there's only so much the developers of Julia and the language itself can do. So we just have to kind of stop and say, okay, well, you got to give us something here. But the idea here is that if we define a pretty small-ish set of functions, we can get basically a new kind of collection without having to do all of the extra work of like writing sorts and all that kind of stuff, right? Kind of like the standard template library in C++, where like if you have something that you can pass to, transform, reduce, or whatever, and has the size method and that kind of stuff, you can get away with quite a lot. Very similar idea in Julia. So what we'll do here is we have this function called isEmpty that we want to define a method for. And if I look here, just to be careful, right, this is a function that is already defined. What does it say? For any collection, it should return a bool, determine whether a collection is empty. Okay, and here's some stuff that we don't necessarily really care about. So what all this means is that this is already defined as part of base. So in order to make a new method for it, just like for any package in Julia, I have to add the explicit qualification here or import it up top here, which I'm not going to do. So I write base dot is empty. And like I mentioned a couple of times, many times, especially if you're writing a function that, isn't already defined somewhere, you're not doing an overload effectively, and you're writing, like a new function for your package that you're not intending to export or whatever, you often don't really need to include any type information in here. It can do what's effectively like duck typing in Python. And without the cost of performance, as long as we define the types themselves correctly. So we always have to be careful to make sure that we're including stuff like type parameters and things where appropriate in the actual type definitions. But then the function definitions the compiler can actually reason about, right? So I do, for this, have to specify that this should be a set, right? Because like I mentioned, isEmpty is a function that already exists, and I'm making a new method for it, so the compiler has to know that this is a new method, right? But if I was having, like count elements or something like that doesn't already exist, and I just wrote set, this would be fine. And this would generate code, for anything that I could pass in here that does whatever I would define in the function. And it would be just as efficient as if I included these type parameters everywhere. So including these type parameters in a function doesn't necessarily give us any kind of performance increase. And we should basically always consider it as part of the type system as opposed to like, saying, because I've written set here, it's going to generate some kind of super optimized code or something like that. It's not like Python where that's a thing. So what am I going to do here? Well, okay, so I do have to specify that it's a set. But I don't really care, for the purposes of this function at least, what type those elements are, right? While it would be totally fine to write this as set brace t, where brace t, I don't need to do that because, at least right now, I'm not planning to use this type parameter for anything. So it's not like a C++ template where you have to, include the parameter whether or not you use it to let the compiler know that you want this to be polymorphic or whatever. Julia will say, hey, this set has parameter t. Whatever you pass me, I'll know what its parameter t is, and I will generate code for that. I don't need to communicate that explicitly unless I need to use the t for something like to generate a new vector or something like that. Okay, so what do I want to do here? Well, the simplest thing, and the place you should always start in Julia, is just a regular loop. So I want to say, okay, well, let's say for each element in set.elements, what do I want to do? Well, if I hit anything, I just return true. Not a return false. Why is this? Well, I mean, the fact that I've made this set in the first place means that there's going to be some kind of vector here. It just might be empty, so this should be okay to just loop through it. And if I hit anything, I return true. If not, I return false. Okay, so let's see what we get here. Oops, and it's kind of mad at me about doing something here. Okay, so what are we doing here? We're trying to iterate through something again. So what I should do here is another common tactic in Julia is to treat the fields of a type as if they're private, whenever that makes sense. Especially for a type like this, where I don't really want to be going and reaching into these elements too directly. So there isn't anything like in C++, right, where I can write like private and public and all that stuff. You can't really do that. What I can do is have a function called elements. Elements of a set equals set.elements. And what this is saying, if anyone who looks at this, and to me in my code is saying, I can access these elements through this function, and that's how it's more or less intended for me to access them. And this is a typical pattern in Julia as well, especially if you're treating a type as something other than just like plain old data. Because in Julia, the functions, the methods tend to be more important. And actually, I've seen the problem here, and this is something that has happened to me in a couple of these exercises, especially for when we're defining things that kind of already exist. And that's watch out to write the name of the type correctly, because Julia actually already has a set type. Right, it does everything we want, including everything that this exercise makes us do. But we don't want to use that, obviously. So what I wrote here by accident is I wrote set instead, and I was getting confused. So now if I write test, I think we should be good. Okay, so we've evaluated something wrong here. So let's see what we've got going on. Oh no, I want to just I think I've confused it by doing that. So let me just start over. Okay, so base.isEmpty custom set. Maybe I didn't save it. Leave case custom set base.isEmpty set custom set. Make sure this works here. Set. Okay, so let's see. Looking through here. Do we have anything kind of obviously wrong? I don't think so. I shouldn't need to like export this, right? Because this is base.isEmpty. If I look at my error message here, right, it's trying to call this constructor. Should be fine. This is fine. I mean, it doesn't really matter where I put this. Let's see here. Okay, so let's think about if there's another way maybe we could do this. If I'm thinking about something, do we have my custom set in both of these? kind of stumped here. Base dot is empty. Return true, return false. So what's going on? This error message is mad because it's trying to call like the wrong constructor. Let's see what that's about. Custom set. Okay, so let's actually look at the other one instead and see if that gives us any useful info. Okay. Yeah, I've just done something. So I've got my structure here. I get that constructor. Okay, so let's see. Let's do something different. Maybe it has something to do with this. Because I do have this custom set. I do export it. I did do, actually let's put this back. I did do my using custom sets. Interesting. Okay. Yeah, let's just try a different approach here. Let's just return true. See if that changes anything. Maybe I'm hitting something here that I haven't seen. Okay, so it's something I'm going to do with this constructor. But okay, so let me just. Maybe it's just something I've done because I've set up this module. Let's do it like this. Let's go back to basics here. Yeah, let's do it like this. Put this back to custom set. I'll just run it right here. This is actually still empty, right? Yeah, let's make it empty. It's from my work on this exercise like a year ago. Okay. And then we'll just take everything that we've written so far and just put it back here. Cool. So in the interest of not trying to debug whatever's going on here live, I will just write it like this. Okay, cool. So we've got this function base.isEmpty for our custom set. All right. So it wasn't that. What we got going on here? Oops. Yeah, we'll just do one at a time. Okay. I think we should be okay. And it's just bad because, of course, I didn't work right. It failed my test because I actually didn't include anything in the test here. So, cool. So let's put what we were going to do originally for element in elements of my set. Return true. Else we return false. Okay. Yeah, why is this test failing? We should have. Here, let's just do it even simpler. Return length of my. No, that should be fine. And in fact, that is required for this exercise. I'm just thinking, looking at the chat here. There was a comment about you're not supposed to implement a custom is equal. Overriding stuff in base like this is, in fact, what you're supposed to do a lot of the time, as long as it's for a type that you've implemented yourself. You should not do this for types that aren't yours. That's what's referred to in Julia as type piracy. And in fact, this will not necessarily work if we don't do something like this, right? But what I was trying to do here is a little bit too clever, so let's just do it like elements of set greater than 0. Okay, right. So this is base dot is empty. Yeah, I mean this is something that should be just fine to do. I'm just kind of blanking on what is the problem here. If I called it by the wrong name or something like that. Oh yes, because I shouldn't really make a difference though. Custom set T. I don't necessarily want to subtype this or anything like that. Well, let's just do something even simpler. Yeah, there we go. So this is simple enough. This is what's called in Julia the delegation pattern, right? Where if you are making a new type, especially a type that kind of, in our case, not quite a wrapper type, but kind of something like it, and that we really just have this one field that is doing all of the work for us under the hood, and we're adding some functionality on top of that. We can just fall back, not even fall back, but delegate to methods that already exist. And here, I could qualify this. I don't necessarily need to, but I could. And that would be a perfectly fine way to do it as well. And actually, again, to emphasize in response to this comment here, despite my, having the classic case of forgetting some details while we're doing stuff live, overriding stuff like is empty and in, like we'll see in a second, these base functions is not only allowed, but is required to a certain extent if we want to satisfy an interface in Julia. So in Julia, we have this collection of, what they like to call informal interfaces, and that they're not like explicitly enforced anywhere or anything like that. But especially if you want to have a type that behaves in a way that matches some kind of other existing ideas, like the classic one is an array. In Julia, we have this thing called abstract array. This is an abstract. In Julia, we like to have abstract as part of the type. If it's an abstract type, this can't actually be instantiated, but there are a lot of elements that are defined for an abstract array, right? If I write a function like this, a abstract array equals, whatever, this is totally fine. This will generate different functions, under the hood, different assembly code for different kinds of abstract array that it sees, but this is totally fine. I don't want to include an abstract array if I can get away with it as like a field and a type, or in a vector or anything like that. But in a function, it's totally fine. And this is kind of like what Julia's answer to inheritance is, where we would define a function that would apply to any subtype of abstract array. And if I go and look here in the Julia manual, which I won't look at now, but you can check out for yourself, they do document some of these interfaces, right? The one that, like I said, comes to mind is the array interface. And that has just a nice little table, right? There's this section called interfaces in the Julia manual that shows you, what you would need to define to have an array, what you need to define to have, a new kind of iterator, that kind of stuff. So this is not only allowed but encouraged. It's just what I was trying to do was kind of failing for some reason. That I don't want to debug live on air here, but I'm sure that someone is probably at home screaming at the screen, shaking it because they figured out what it is. Okay, cool. So for this, right, we're just going to fall back on saying, okay, well, this is a vector. This has this is empty function. Let's just go ahead and use that under the hood. If I go back to my run tests, that gives me these two tests. The next thing I want to look at is this contains function. Right, or in. And again, what we're going to want to do here is something like this, right, where I have a function. Again, this is in base. I'm going to say in x s for a custom set, not just a set. And you might say, okay, well, what's going on here? Shouldn't I have something like this, right? Right, where I at least make these match. And again, this would be totally fine. And in fact, there might be some cases where you'd want to do something like this, where you'd want to kind of enforce right away that these are the same type. But again, in Julia, we do like to take advantage of the fact that the compiler is pretty smart and say, okay, well, we'll leave this out for now. If there's a reason why we would need to explicitly enforce that these are the same type or, use this type parameter for something, we will. If not, we're going to say, hey, whatever goes in this first spot that is kind of compatible in any way with what we're going to implement in this function is good. Let's go ahead and use it. And what's that going to be? Right? Well, in this case, I will use a kind of iterative approach and say, for each of my elements, if I go element by element, if any of these elements are equal to what I pass in, I return true. If I make it out of this loop, I return false. And again, something to emphasize here, especially since we are kind of talking about differences from Julia relative to other languages. This is a totally performant way to do this. Right? In fact, basically anything else we do in Julia will boil down to something like this, right? I could use a built-in function and write, return, any is equal x for any of the elements of S. This would be a totally equivalent, slightly more functional way to write it. This will compile to basically exactly the same code as what I just wrote. So, I mean, this is a good way. I'm becoming more and more interested and a user of the functional approach. This is fine, but especially if you're starting out and you're just trying to figure out what to do and how to approach a problem, doing the kind of simple for loop based approach is not only good, but in many times the kind of most performant thing you can do. And I'm going to override this function in. I want to think about that. It's this kind of like, what's it called? Reverse Polish notation, I think someone told me last time. And that this is like, what I write is X in S. Actually, can you do it in Vim? Yeah. Okay. So in Julia, we do have this kind of Unicode stuff. If I write /in and then type the tab, it'll replace it with the math symbol in. I don't really like to use this all that much, just because it's super weird if you don't use Julia a lot. It makes it really hard to search for stuff in IDEs and Vim and stuff because how you gonna? I mean, you can do this, but it always throws me. So especially when you're working on function overrides and things, I do like to use the actual names instead of the symbols. And most of the time, the compiler will know to swap them out, or the language will know to swap them out based on what's already defined. So if I run my tests here, looks like I'm actually good for these inclusion tests. Sweet. And hopefully we'll be able to get through at least a good chunk of this. I did burn some time trying to debug that issue before, but c'est la vie. So I want to have this is subset function. I think this is one that's in here too. Is subset. Yeah, so this is already defined. Strictly speaking, if I was thinking about the perfect world where there wasn't a set function already, or a set type already defined, I wouldn't have this is subset existing already, but I do. So what I will do is call this, function base dot is subset. Okay, make sure I spell that right. And we'll have one set, two set, custom set. And again, I'm going to leave these type parameters off. If I can compare these in a way that makes sense without checking the types, I might as well. The compiler will be able to say, this is S1 is whatever type. Let me generate whatever instructions to access the elements and all that stuff without me having to intervene. And what does it mean mathematically, right? A good way to think about a good ways to write Julia code is what does the math look like? Because a lot of times that is a perfectly performant way to write things. So what we'll do is something similar, right? When we talk about, A subset B, again, I can do that little thing there with the Unicode. What does that mean, right? If and only if for every X in A, X is also in B, right? That's what this means. So what we'll do is say, okay, well, for all of the elements in A, Actually, here, I'll just even use the same notation, right? A and B, why not? S1 and S2 is kind of clunky anyways. For each of these elements, well, what do we want to do? We would just want to go through all of the elements of A and make sure they're also elements of B, right? So if it's not, right? So if this element, and it should be elements, it should just be one. If this element is not an element of B, we stop, we're done. We found an element that's an element of A, but not an element of B. A cannot be a subset of B. Again, if we make it through this loop, we've gone through all of the elements of A, we've checked that they're all in B, we're done. So let's see here. We've got okay, a couple of errors. So let's check out. Okay, so my test failed. I passed in 2 subsets here. Sorry, in contains. Okay, so let's see now what is causing our problem. I did spell it right, didn't I? I probably wrote set instead of. Oh, these are both custom set. Okay, I don't need this stuff. Is subset is part of base. I like spell it wrong or something. For each of the elements of A, check if it's an element of B. If not, return false. Let's see here. So my test failed because these should be subsets of each other. So let's see. Oops. This should be true, of course. Yeah, screwed that up. So you might notice here I'm using this pattern of, as opposed to having like nested for if statements and, having like a, found variable to track it. I'm going for this early exit approach, right? Where I go through this loop. If at any point I hit this condition, I just stop. I'm done. I don't have to keep checking. Right, and that will save me some time in terms of execution time, especially if these are big sets, because I don't need to like check how many failures there are or anything. I can just stop. Okay, and I think that's actually good for this test set. Cool. Okay, so now we have this disjoint function. Is that one? Okay, so this actually isn't already part of base. So we're gonna make this a little bit bigger. So I don't need to prefix this. I can just do function disjoint A custom set B custom set. Right. And you might notice here, right? Even though, if I looked at like the is subset, right, it has this notation that tells me, what the return type of this function is, and this is something we usually do include in documentation and stuff like that. And we could, if I really wanted to, write like this, right, and say that this returns a bool. There's really no need to do that. It's not usually typical to see that kind of thing. I think mostly just because it's not necessary, and also, you might want the flexibility of returning different types depending on the input types, right? So we do want type stability, in that we should be able to figure out what the output type looks like from the input types. But we don't necessarily want to keep track of that, right? It's for a similar reason, keep track of that explicitly, I should say, for a similar reason why we don't necessarily write these type parameters here, right? What I could write here to make this, fully general and, equivalent to what is actually being generated here is have like, TA, TB, or TA and TB. I'm not really going to restrict these. I guess it probably would make sense for these to be number types, but I'm not going to do that. But since I don't need to use these type parameters anywhere, I'm just going to leave these off. And as for disjoint, well, I mean, 2 sets are disjoint if, they contain none of the same elements. And if I think about how I would check that, just like sitting down, if I had 2 groups of things and I didn't know what else to do, and I wanted to make sure they were all different, I don't need to count all of them, right? I just need to go through, say, like one group and say, okay, well, in the group in my left hand, item by item by item, check against the other group and say, do I see any repeats, right? Do I see any of these items that are the same? And I only need to go through that first group, because if I go through that first group and I haven't hit any common items yet, then I'm done. There can't be anything in common. So what I can do here is the same kind of thing for each of my elements. The opposite now, right? If this is an element of B, I return false. Or, then again, if I make it to this whole loop, I'm good. Oops. And if I run my tests here, and one alternative approach that I think should be just as good, right? First of all, we could write this as like I said, we can use this kind of symbol if we like, because it's just like the math notation. I can also write like this. All because I've defined this method up here, right? These are all basically the three things I've written here. Of course, I'm going to write something that's not syntactically valid just for illustration purposes, right? All three of these lines are the same. And I only need to define, this first one. It's usually best to use the actual kind of explicit version in your actual definition, and then you get all the others for free. So as for which one I tend to use most often, I actually tend to like this, because this is like, what I've written right here. Since elements already has this function in defined, I can use this notation here. I could also write, for in, else a, I could write it that other way too. I'm not going to do that, of course, because that's super unnatural. Okay, and one thing I could also do that should be equivalent is, return if A isn't a subset of B, then they've got to be disjoint, at least for the examples that we saw. So I'm actually going to write this the way that makes a little bit more sense to me. Okay, so what's next here? Now we have equivalence. So here's another one, right, where we have this equals symbol, but it's usually safer to actually define your function as is equal, right? So we have this one, of course, is in base. Custom set, B, custom set. Again, I don't care what the types are as long as it makes sense to compare them. And if I think about set theory, whenever I want to check if two sets are equal, I check two things. Is A a subset of B? And is B a subset of A? If these are both true, right, then A and B, if and only if, right, A and B are equal. So let's see what we get, right? If I write return A subset B and B subset A, and I'll put in the space here. And I think it's going to get mad that I've used that notation, so let's just be careful here and write is subset B and is subset A. Let's not get too fancy. Okay. Dot is equal. Actually, this is one of the cases where I've flubbed and actually want to find this one instead. I think it is. Yeah. So this is something that does kind of get a little bit screwy sometimes, and that usually I just have to try out a couple of different combinations. Strictly speaking, I should probably make sure to define all of these different, is equals and symbols and all that stuff. Equals, I think, is an exception just because, this isn't like a Unicode symbol or anything like that. Whereas, this subset in and all that stuff is. But I think actually just writing it this way, which is a totally, valid and even performant way to write this function. I could write another, double set of loops or whatever, but I'm not going to do that. And let's see here, right? So what I could do then is look at the rest of my tests. And now I want to do add. Right? What does that mean? I'm going to be pushing some elements into this set. So if I think about a set, sets don't have any notion of order, right? But they do have a notion of repetition, right? If you don't count repeated elements in a set, you only count the one, at least most of the time. There are occasions where that's not exactly true, but in general purposes, you don't have like the set of 1, 2, 3, 3. It's just 1, 2, 3. And that's what we're going to use for the purposes of this exercise, especially for ambiguity. So if I think about this, all I have to do is define this function called push. This is a pretty typical pattern in Julia where we add an exclamation point to functions that mutate one or more of their arguments, and usually like to put the mutated variable first. So this is like pushback in C++, right? We're taking this collection, we're pushing an element into it. And so what do we want that to mean? Well, this one is in base, and I want to push into my set. Push a new element in there, right? And, well, the only way I want to push it in here is if it isn't already in there, right? So I want to say, here we'll do it like this. If not x in elements, push x. So what am I doing here? Well, I'm checking. I'm saying, well, as long as x isn't already in this collection, right, like my internal, buffer of variables that I'm storing, I go ahead and push it in there. If it is, I do nothing. I just move right on. And the one line to also mention is this right here, right? I've written elements equals elements of S, right? This should not make a copy. It should basically make, a new, in Julia we call them binding, kind of like a reference. We have several bindings to the same variable. In this case, right, we have this elements. We're pushing into it. And then, of course, we don't want to return anything. I can write just return, not noting. Return nothing. I usually like to write the explicit return nothing. You can also just write return, but it's a little bit weird. So let's see what we get here. And that's all good. And the reason why I've written it this way is just to save typing, right? I could just write, elements s dot elements, whatever. But this is writing, this is like if I wrote in C++, right? If I wrote like auto elements is equal to elements of s, or defined elements to return a reference or whatever. This is not making a copy, and is also letting me access the internals of this vector, write new stuff to the vector, index into it, that kind of thing. Just let's make sure this is saved here. And like I said, this is mostly just to save typing. Okay, so let's see what's next. Intersection. Oh, that should be a fun one. Cool. So let's see how much of this exercise we can get through. I only have like about an hour and a half or so technically, but so I will like to get through at least a good chunk, but I don't think we'll get through the whole thing because there's a good bit left here. All right, so let's go one step at a time. Okay, it looks like we have in place versus not in place versions. So that's also pretty common in Julia, right? Where we have operations that either mutate their elements or don't, either for performance reasons or whatever. And it's also pretty common to write, the non-mutating version in terms of the mutating version, that kind of thing. So let's start off right here. So we have two sets. They're both empty. We want to compute their intersection. And since we have this exclamation point, we want to compute their intersection in place. So what we're going to do is compute CS1, right? So we're going to take the intersection and overwrite CS1 with that intersection, or, replace CS1 with that intersection. And if we think about how we're actually going to implement that, most likely we're just going to operate on the internals there. Let me make sure I've got everything right here. Make sure I can still include this, and I haven't missed an end or something like that. Yeah, cool. So it doesn't know what I want from this intersect. That stinks. So let's see. custom tests. So we'll do, I think intersect is already part of this. Yes, there already is an intersect thing. So we'll do base.intersect. And it's 2 sets. So we use A and B because it's a pretty common notation. And we're writing into A, right? We don't have to write like consts and anything like that, right? If we pass in stuff that can be mutated, then we will. You might say, hey, you know, I haven't written this as a mutable struct. How can I actually mutate this? And the elements, the vector, is mutable in the sense that we can change its elements. We could add elements to it. We can't change the type that this vector contains, but we can, you know, if I start with x equals a vector of just floats, it's empty. I can, you know, push stuff into it. I can then rewrite that stuff that I pushed, right? Even though it's technically considered immutable. So the thing that I can do with this custom set is, even though the set itself is immutable, right? I can't change this type parameter. I can't change the underlying type that this element is, but I can change the elements that it actually contains. So, and Julia has this kind of somewhat different sense of mutability that's more focused on types than on the actual data, at least in most cases, right? If I have a variable that is like an integer or something, I can't mutate that, at least not in place. So what do we want to do here? Okay, so I want to mutate it, so I'll do something like, let's see, the elements of A is equal to the intersection of the elements of A with the elements of B. And then what we usually do when we have a mutating function is return the thing that gets mutated. So let's see what that gets us. Cool, it actually gets us quite a lot. As far as what else we could, let me just make sure that this will work real quick before I go ahead and try it. 2, 3, and then do like x elements is equal to 1, 2. Yeah. Okay, so I can't necessarily do stuff like this where I rewrite, because what I was thinking what would be good to do is to like have like, you know, common elements be like, in this case, I would have to mess with the types and say, you know, this is type A, type B, and do like type promotion and stuff. This is nice because I don't necessarily have to do that. But another approach here that would be good, because it would actually use stuff that I've already... No, this is actually probably pretty good. Yeah, this is a simple enough approach. There's all kinds of stuff we could do here, but let's keep it simple for now. Oops, and this is the wrong one, of course. Custom set. That's the file I opened before. Run tests. Cool, and I think that actually should get us a decent chunk of the way there. Let's find out. Okay, so our test failed here. Why is that? Probably having something to do with the sorting, right? I bet if I take this and just run it here, CS1 is this, CS2 was just 3,325. 5, and then I bet if I do the intersection, oh, wait a second. Yeah, what's going on here? So we picked up this 4 as well. I bet. Let's see. Let's see what we got here. There's probably some shenanigans because I've done it this way, so let's take a guide elements. Yeah, I bet it's because I have the elements A on both sides here, so let's see. Oops. B not defined because I made it lowercase, of course. Immutable structure. Oh yeah, because I'm trying to do exactly what I couldn't do before. Yeah. So I think I got it here. So what should we do here? I think we can just use this empty function, right? If I just do empty elements CS1, right? Yeah, cool. So what we'll do is we'll do it the simple way of saying else A is the elements of A. And actually, we'll copy these. And we don't need to copy the elements of B. But then what we'll do is we'll empty out the elements of A. Cool. Make sure that, okay, that did take. And then what? Then we'll do for, so we loop to the elements of A. And actually, yeah, no, let's do it. This is actually even much smarter. Yeah. If this element is also in the elements of B, so actually we will just go ahead and take both. So we don't allocate that variable a bunch of times, but it's probably smart enough not to do that, but we'll be safe. Right, so what we're doing is we're taking these two sets of elements. We actually don't really need to copy the elements of B. The reason why I'm doing this explicit copy here is because I'm emptying out what A actually contains, and then I'm replacing it. Actually, what would be even smarter here is this, now that I think about it. Let's see, delete. Yeah. Delete the mapping for a given key in the collection. Yeah, I don't think this works for delete that. Return the items and so yeah, so if I do, let me just make sure I'm remembering how to do this right. 1, 2, 3. Come on. Yeah, sweet. So we'll do it this way. We will loop through for I in each index of the elements of A. So we'll do the same thing here. I'm not going to copy this because I actually do want to be able to and then we'll delete. If yeah, it's not. What's I in B? So if this isn't in B, then we delete it. Oops. Oh, of course I want to do that. Oh, I bet. Oh yeah, of course this is going to work because once I delete the vector and I go to the next index, it's going to be wrong. So what we'll have to do is, the smartest thing would be to just store the elements, right? And say, yeah, we could do that. Right? We could just say, we'll collect all the bad indices. And then we'll delete these from the elements. And then we'll return A. Yeah, cool. Yeah, that's just one of many ways to do this, and the way that I kind of latched onto was just going through and saying, we go through each element of A. If it's not also an element of B, we mark it down, and then at the end we just delete all of the ones that aren't elements of B. My first approach of making 2 copies would probably also be fine. I don't really know that one would be much more performant than the other, to be honest. But this is a neat way to do it that I think kind of makes sense. So let's see what else we can get through. I think there is a non-in-place version of this intersection that we could do, which is the one that kind of makes a little bit more sense. Custom set. If I do this intersection, so let's see. Make sure that this is 3, and if I do like A equals that. If I do like B equals A, making sure that I remember how this works. So I don't want it to be 1, it must be something else, 5. Okay, so this is what I was making sure that I remembered right. So this kind of thing where it just because I made an assignment doesn't necessarily mean I made a copy works for even this custom set, right? Because of the fact that it has this vector inside it. So for a non-in-place intersection, what I will do is basically what I was thinking of doing originally, right? Where I have function base.intersect without the exclamation point, right? Because this time I don't want to mutate any of these arguments. Because what I'm going to do is have, elements. Actually, we'll just do it like this. Return custom set of oops, it should be a capital B. Oops, and interset. That would be a neat name for it, though, wouldn't it? Cool, and that works. I guess one way, if we wanted to make use of our own code a little bit more, one alternative that we could do would be to do something like if I did B equals copy A. Oh, I haven't made a copy for that. I could do something where I did like, C is equal to custom set of the elements of A, to make sure that I'm not copying this and that I'm actually making a new set, and then do like return intersect exclamation point C comma B, right? Because then I compute that intersection. I mean, that would be neat because I'm using more of my own code, but actually I think this is a cleaner way to do it because this is a little bit more idiomatic Julia, right? Where I am kind of using stuff that's in the base library wherever I can. And let's see, maybe for our last part of this that we'll look at. Now I want to look at, a set difference, right? A complement, which is, where we take two sets and subtract one from the other. We remove all of their common elements from one set or the other. In this case, we're going to want to do this in place. Right. So let's see, we'll do something similar to what we did for the intersection. I think complement is part of this, right? No, actually, okay, complement isn't already defined, so we can just do A custom set, B custom set. And what we'll want to do here is the same kind of thing, right? Where we'll have the bad indices that we'll collect. Actually, this would be a good place to use filter, right? So we have this kind of more functional approach. So what I'll do is I'll use the filter function, filter exclamation point, because I do want to mutate what's in place here. And for each, what we'll do is X gets mapped to, so for each element of A, what do we want to actually apply to it? We want to do X maps to Let me make sure I remember right. Filter is everything that's false. Yeah, okay, cool. So we only want to filter out the things that are also in B, right? So let me make sure I'm thinking about this right. So this is false whenever X is actually in B. It's true when X is not in B. Okay, cool. So I think it should be good. Do they want like an in place? Oh, because we didn't define both. Yeah. Okay, and we can actually just go ahead and define the other one too. Not in place. And what we'll do here is we'll have a new set, right? And right complement doesn't already exist. I mean, it does because I imported it there. But what we can do is think about the elements. So actually, in this case, since we can't really do something like quite as easy as this, we'll do kind of what I was thinking of before, which was to have a new set where I just copy in all the elements of A, and then I use the in place complement. This is a pretty common pattern in Julia, where if we want to have one version in place, one version out of place, we kind of use one inside the other, and it also makes for less testing. Looks like we are all good. Oh, it's because I don't want this. I don't want this to return the elements, right? Okay, so I filtered. Do I just have this backwards? Custom set equals. So this is for my out of place complement. Okay, so this might be one that will take a little while to think about. So this might be a good place to call it a night. Yeah, so in this case, I think that, I have gone a pretty decent amount of time now. And once we get to the point where we're starting to see a couple of different errors in a row, it's usually a good place to take a little break and work on something else for a while. So thanks everyone for being here with me tonight. I appreciate you taking the time to work on some Julie with me and bearing with my mistakes and typos and all that stuff. It's really been a great time this month to get to do this stuff for Exorcism, and thanks for taking the time. And I will maybe be doing some live streaming of my own. Haven't really decided yet. So if that's something you're interested in, you can see my name, Aaron Carta. Go ahead and look me up on Twitch, and maybe we'll see some more stuff soon. So with that, it's been a great April. I've had a great opportunity to do this stuff, and have a great night, everybody.